So a common question that's often asked in the context of AI in healthcare is, will AI replace the doctors? So I'd like now to ask that to each of you, and what you envision AI in healthcare will look like in 5 or 10 years from now, and what areas of medicine and of clinical practice will AI be the norm by then, and what this will look like. So let's see, we can start from Jenna.
Sure. So I think, as many of us alluded to, no, AI is not going to replace doctors. We rely too heavily on your domain expertise. And I think what AI can really do is augment healthcare professionals so that you can do your jobs even more efficiently than you do already.
Yeah, I would definitely echo those points. I think a particularly good example of that is the fact that we're a team of 16 engineers, but with 70 radiologists. So even to build these AI solutions, there's tons and tons of work for radiologists to do in that. And the end is nowhere near. The amount of data required to build these things is never ending, and it's always something that's going to keep learning. And even beyond that, we're never going to be as good as people in certain areas. And ultimately, the best solution is always going to be the hybrid. It's going to be person plus machine. And I think we're definitely jumping the gun by trying to move past that so quickly.
I totally agree with that. And I would add that while it will not replace clinicians anytime in the near future, I think it will change the knowledge base that we have to have as clinicians. And so as we are using the systems more and more and getting exposed to the unintended consequences of information services, we need to take on a new body of learning and understand how to safely incorporate these technologies into our practice.
And I would build on that for sure, because I do think that you'll see the nature of some of the work change. And if you look back at history with like computers, they used to be people and they would just punch numbers. And once we were able to program and we could actually just have the machines do the computing, we moved to a bunch of programmers, and that's been a big industry. I do think that you'll just see the evolution happen, which is people will evolve to adapt even more new skills to synthesize the data that's coming out of the AI technologies.
So actually, a follow-up to that is this issue of how machines and humans will be working together, and these ideas of robustness and reliability. And so this is something that's been coming up in the news recently with autonomous driving, which is another application area where we're trying to figure out how how AI will be able to assist humans. And so we've seen there some of the recent news headlines where sort of imperfect machines, even if they may be better overall than humans, will still lead to catastrophic errors. So how do you see this playing out in medicine? And how should we be sort of mitigating these kinds of risks and sort of looking at the evolution of how AI can be used in these assistive ways?
So in terms of patient risk stratification tools, I think that as machine learning researchers, we do a good job of making sure we have a training set and a held-out test set, but it's still all retrospective analysis. And to really, before we start intervening based on these predictions, it's so important to prospectively validate the model on real streaming data. So I think that's a crucial next step.
Yeah, I think to start that, in our case, we like to deploy our models in stages. And the first deployment for us is always quality assessment. Retrospective, learn to see how the models interact with specifically their incidence of patient abnormality, of anatomic variation, their quality of machines. We need to have it in the field for a reasonable amount of time to understand that it's actually working for their specific use case before we gradually progress it into more and more prospective use cases. But I think it's an interesting analog to the self-driving car example, because a lot of what creates problems there is overdependence. It's people grow too confident in the system, and so they think it's okay to just lay back and put their feet on the wheels and let the Tesla autopilot go. The FDA is growing increasingly more fearful that in medicine that is also going to happen. And that's why we like to play tricks like intentionally show the radiologist the wrong output to see if they're going to change their mind as a result of that. And I think it's critically important to be doing studies like this at this point to understand, as I know Katherine had alluded to in her talk, about the user experience around this and how it actually interacts in the ecosystem to see how people will interact with this solution.
Yeah, as an avid bicyclist, I am incredibly excited about the potential for self-driving cars. I frequently see cars driving right through the middle of the bicycle lane, and I think the self-driving cars have the potential to significantly improve that factor. And I think the same thing applies in medicine, right? So self-driving cars have some pieces that they're going to be very good at and some pieces that they're not going to be. And if we over-rely on them in the wrong situations, it's not going to be helpful. The same thing that you're saying in medicine, it is applicable. We have to understand where AI can be helpful, use it in those situations. But every single patient that we encounter is an individual study, and we have to determine whether the presumptions that we're basing our decisions on are true and are working for that particular patient. It's not all that different from the lab data that we get that may be false because the experiment or because the lab didn't run it correctly. We take the information, we use it to implement it into our decision making, but we constantly have to keep checking and making sure that our assumptions are right.
Yeah, and part of the point that I was trying to make with the human-centered design is it's not only important for having impact, but it's actually making sure that you have patient safety in consideration when you practice those principles. And I also think there's other ways that you can go about this, which is ensuring there's guardrails with independent review boards and having ethics committees, but also sometimes you can have like red teams where they intentionally try and break the system and see where things could go wrong. All of these are important things to employ in terms of making sure that you've thought through like all the implications of the AI model.
Thank you. So let's move on to audience questions. So let's start over here with Carlos.
So I want to thank you all. What an incredible panel. Just wonderful job. I want to ask you each sort of for your high optimistic, in 5 years, what's the thing that you're really hopeful will happen and that people will be pleasantly surprised by, the sort of the delight side? And then what's your Black Mirror kind of fear sort of thing that, you worry about at night, you're like, oh geez, I'm creating either Skynet or I'm gonna get discharged with the wrong treatment plan and I can't do anything about it because nobody will pick up the call. So if you could each take that'd be great. Serena, I'll even ask you to jump in there.
Okay, so I guess we can go.
Sure, I can.
This time. The other way, maybe.
Okay, go ahead.
Oh, okay. So what would be delightful for me is if actually one of the futures I'd like to see is where technology is in the background, it's ambient, and you really don't actually spend much time interfacing with it at all, or you don't feel like you are, and it's there to be entirely assistive. And so moving towards that general type of AI is something that I would be excited about. In terms of what I would be concerned about, I think mostly what I've been concerned about is if a system is structurally inefficient, technology is just a tool to scale up and superpower whatever that system is doing. So if you apply it to the wrong systems, it will actually increase the amount of inefficiencies that are happening if it's inherently inefficient. So that's what I look for, is to make sure that we're applying the technologies in the right spaces.
So similarly, my dream is for technology to be in the background, and both for the application of AI in our decision making, but even more so, you can imagine as a CMIO, I am constantly hearing about the changes in physician workflow and the contributions to burnout. And I do believe that in a few years, we will be at a place where we have, auto scribes, digital scribes that can capture the information from our healthcare workflows without, again, people being that intermediary. So I envision that day, and I envision the tools then in the background helping to guide our care. I think my fears are that it will take longer than I'm hoping to get there. And then the unintended consequences of people forgetting their role as a physician or a clinician and double checking. We've seen so many times examples of where people have suffered from automation compliance or complacency or over-reliance. Some simple examples even was when we put in our electronic order set, electronic order sets, and we would create order sets that pre-checked a certain algorithm or certain test, and expected the physicians to review that. And what we found was that suddenly neonates were getting ordered for pulmonary function tests, which they couldn't possibly do. And so it increased our compliance with our older asthmatics, but for the inappropriate kids, all of a sudden you're getting orders that made no sense. And so I'm really worried about how do we train physicians to use these tools responsibly, to make sure they are evaluating and putting in their own clinical thought in the right places, and then again, double checking those assumptions and making sure they are getting the right outcomes for their patients.
I think on the research side, as far as the technology goes, I'm expecting a lot of advancements in the next 5 years. But unfortunately, there are many reasons why only on a time span of 5 years, I don't necessarily see those propagating throughout the healthcare ecosystem. One, that infrastructure in most hospital systems is 30, 20 plus years old. And 5 years is not a lot of time on hospital infrastructure timelines. So what I am hopeful for is that over the next few years, people will start to invest in these changes that are going to be required in order to actually push these solutions out in a meaningful way going forward. On the same note, I'm hopeful that the FDA and other regulatory bodies, not just in the United States, will also start to have a better understanding of how to validate these solutions in a far more sustainable way so that we can start to see more regulatory buy-in in these types of tools. I think most of my Black Mirror scenarios aren't really tied to anything like general AI. I think that's more like 500 years away than 5 years away. But at the same time, what does scare me on a 5-year timeline is people meddling with things they don't necessarily understand or appreciate. People that are data scientists purely in a lab trying to build AI for pathology, radiology, ophthalmology, et cetera, ology, without interacting with the people that have actually been doing that and building the medical knowledge of how to do that by hand for hundreds of years. And I think that leads to a lot of immature solutions based on immature assumptions going out into the market, and that can have horrible downstream effects. So that is what I'm actually quite concerned about.
So the optimist in me sees no more C. diff in 5 years. How are we going to get there? I think it's a combination of ambient technologies, as was mentioned, and ambient sensing, because there's a lot that's not in the electronic health record that our models are missing, and I would love to include those variables, things that we're sensing ambiently, and also data from the microbiome. So we're doing a study now where we're collecting data from the gut microbiome and looking at correlations with risk of infections with C. diff, and it would be wonderful to have daily samples. So I think more data would be great. In terms of the negatives or downsides, or what keeps me up at night, is the fear that we're overfitting or we're picking up on correlations that aren't there, or that we're getting tripped up by a lot of, there's so much confounding. These data are really high dimensional, a ton of collinearity, and we can prospectively validate, but then as soon as you start intervening, there's this feedback loop, and it's really scary because things can spiral very quickly. So that's what keeps me up at night.
And I'll pitch in and add my 2 cents as well. Where I think adding on to some of what's been said earlier, I think some of my greatest hopes as well as my greatest fears are centered around how effectively we can actually integrate AI into this day-to-day workflow of clinicians. I think as was mentioned earlier, if we can do kind of a seamless job of this, this can be very, very useful. But on the flip side, alarm fatigue was already alluded to earlier, and I think my fear is that if we don't think enough about sort of what clinician workflow actually is and how we can integrate this, that AI is just going to turn into a bunch of sort of alarms and alerts of us as AI researchers, just trying to give out our knowledge every time we see something interesting, and just sort of deluging clinicians in a way that it's not going to be effective, and sort of even progress in future development and deployment will be hampered as a result. And then adding on one more thing as well, I think one of the things that I am very excited about in addition is what sorts of new knowledge can we actually be able to gain and extract from being able to use AI to be able to interpret and understand what's actually happening in healthcare, what the outcomes are, and what types of interesting insights we can gain from that. Okay, so next question. Let's go to this side.
Hi there. My name is Mike Meehan. I'm part of a stealth mode startup. I'm a physicist rather than a physician. I have a question with respect to entropic uncertainty and this concept of how the brain deals with lack of knowledge and being able to do this sort of interpolation. When we look at the way AI systems work, they use an incredible amount of horsepower when the typical human brain uses around 50 watts. Yet we seem to sort of be able to match that performance. Is there something fundamentally wrong with the way we're approaching AI, with its linear models? That we're sort of like almost in a sort of geocentric epicycle approach to problems. Should we be looking for something that steps outside of that and looks at more of a solar kind of model that may explain things and be more performant? I'd like to understand the panel's thoughts in that area.
Who'd like to answer that question?
I'll take a first pass. So it's definitely compute intensive when you're training the model, but once you have the inference model, it's actually very minimalistic. It's just computing through a bunch of numbers. So it's imagining that you as the human brain, your entire life, there's tremendous amount of energy, I think, going into the development of the brain when you're growing up. And that's the training bit that's happening, except we're only solving one particular problem at a time. So I do think we will get more performant over time. There will be better methodologies that will evolve. But I also think that the training is separate from the actual inference model that get called.
Yeah, I would say that this is a particularly challenging topic just because I don't think anybody really fully understands the way that the human brain works or how you would map that out as an architecture, though we can take some inspiration from it. I think from a lot of the research I've seen in specific areas, it does suggest that as we try to closer replicate either what we understand of it or specific elements of what we understand of it, it can help improve performance. But I think the brain is just a fundamentally incredibly complex, naturally evolved thing that has evolved for the types of tasks we encounter on a daily basis, and it's fairly specialized for those types of things. I think to grossly oversimplify that line of thinking, we found that even though I characterize it as a black box that is sort of independent of whatever the input and output is, the closer that we tune that to whatever knowledge has been generated in the field of the task we're replicating, it helps quite a bit. In our particular example, giving the network an architecture or at least functions that replicate the types of functions that radiologists have learned to do when interpreting images themselves has greatly improved our performance. When radiologists look at a CT scan, for example, they window it. They try to limit their field of view to specific types of densities. And implementing that same functionality into a neural network improves its abilities to interpret those images, unsurprisingly. So I think that in very particular fields, we're going to gradually learn more and more from what people have already learned to do by doing this manually in all these different fields. And ideally, eventually that will converge on things that closer and closer replicate an ideal architecture for more general tasks.
Yeah, we've been able to make tremendous progress from an algorithmic perspective, and hardware is still catching up. And as we continue to develop more specialized hardware for these algorithms, I think you'll see performance improve greatly.
Okay, question on this side.
Hi, Merle Dorhoff from Stanford. Thank you very much for very interesting presentations. My question is largely directed to Katherine. You mentioned some academic studies in your talk, and I'm just wondering to what extent one should keep potential publication bias in mind in thinking about the generalizability of the results in terms of the performance of the algorithms.
Publication bias? You mean, can you just elaborate on that? Do you mean like being biased towards research, or?
No, so you say you of the projects that you published one project, but you might have run 10, and the journal only is interested in publishing results where the algorithm does better, for example, or where we don't see a publication of a study where the radiologist actually performed better than the algorithm.
Oh, because we did one on diabetic retinopathy, but we didn't show like radiology or pathology or dermatology. Is that?
I'm sorry if I'm not being clear. So not necessarily a bias on you or your organization, but a bias in the publication process at the journal where they don't, where they're only interested in publishing certain results.
Oh, okay, I
and
see what you're saying.
Not everything.
Yeah. I think what we found is, because we're sitting at the nexus of AI and clinical, is that certain journals are interested in certain publications. And what we're most interested in making sure of is that we've peer validated the results, that we've had good, robust feedback. And so we actually tend to try and apply to both clinical and technical journals at the same time, just because we want to make sure that we're being as robust as possible. And yeah, I think certain journals are interested in certain types of material, but so far, at least I feel we've learned a lot in the process of working with all different publications that we've had to go through.
But this is exactly, and this is our responsibility as a field as a whole, is to publish, both the kind of dramatically positive results as well as cases where we didn't have such robust outcomes, and that's truly how we help, how we learn, how we understand what went wrong in the cases where we didn't get the right answer, and I think we're seeing, more and more in the field of healthcare, and hopefully more and more in data science, where there are journals continuing to publish so-called negative trials or cases where it didn't work out, and I continue to encourage that because it is important for helping us move the whole field forward.
Yeah, and for what it's worth, I would say that the research I've seen out of Google in this area is probably the best I've seen in the field. But that said, it is definitely a problem in general that we come across. I would say the majority of papers, particularly on the AI side, are almost impossible to replicate. And that is very, very unfortunate. I think that this is something we've all known about published research, regardless of any industry. But I think in AI in particular, it's a lot worse because it's easier to iterate on these things, and it's a hot field, and people are eager to get papers out there. But it is something that at least I'm personally quite concerned about.
Okay, so we have a couple minutes left, so let's try and squeeze in one or two more questions. So let's go over to this side.
Sure. This is Sandhya Balasubramaniam. I'm from Genentech. So this question is for the complete panel. So while we are preparing the data to feed into the AI algorithms, I think all of you at some point have made this clear that garbage in, garbage out, and model is based on the data that you feed in. So I just wanted to get your perspective on some key challenges and learnings that you can share with us in terms of how to prepare this data that can go into the algorithms for better predictions. Yeah.
Yeah, so this is actually specifically my field of research, and it's something that I've come to love in medicine because it's very interesting to study these diagnostic workflows very closely. But unfortunately, it's, as I had mentioned before, a very nuanced thing that requires a lot of domain knowledge in specific areas. The first study that we ran was around wrist fracture detection. And I think it's a really good example of this because we built a model to ingest a wrist X-ray and produce a circle on that scan surrounding any fractures that might be present on it. And we ultimately deployed this with our partner Capital Health and found that radiologists using it were reading scans about 20% faster and around 10% more accurately. But in building that model, originally we had pulled scans from Capital that, based on the reports, suggested might have a fracture. And we served it to a team of radiologists and instructed them to circle all the fractures. Unfortunately, that is a very generic prompt. It's a lot more generic to a radiologist than it probably sounds to those of us that aren't. But what we found is that there's a lot of corner cases, and people did not know what to do. And different people interacted with it very differently. And what we ultimately found when training the model was that it did okay, but when we looked at the actual training samples provided by each radiologist, it was very clear where some of those biases came from. One radiologist was totally off the mark. He was circling a lot of malfused growth plates that he mistook for fractures that we were not explicit about excluding. And when we eliminated him, results went up, but we were still getting a lot of false positives. And when we looked at one of the other radiologists, we found that all we told him to do was circle the fractures. So he circled them as tightly as humanly possible. But if you zoom in enough on a fracture, it just looks like a line. If you zoom in enough on anything, it just looks like a line. And so it was kind of biasing the model to place attention too closely on this model, or this feature, without taking into account the features surrounding it. It's the healthy bone tissue around the hairline that makes it a fracture. And so what we did was programmatically expand all the ROIs on his annotations and retrain the model, and that had amazing results. But ever since then, it's sort of trained this mindset that we need to be overly meticulous about this, which is why, again, we test people in 2 phases prior to putting them on the system, and then we continually QA them every single week by serving some subset of cases the same to everybody that's in that particular buffet of tasks, as we would call it. And then a specialist or subspecialist reviews those each week to give them that feedback by phone. So I'm hopeful that, in particular, advances probably from groups like Google will lead a lot of work in unsupervised learning. I'm actually very much rooting for that, even though it's counterintuitive to my research, because it'll save me a lot of time and money. But I think that that's probably going to be the biggest solution to this. Otherwise, it's just going to be a lot of hard work.
Thank you.
Okay, so we're unfortunately out of time, but I think the speakers will be sticking around a little bit afterwards if you want to find them at the lunch coming up. So let's give another round of thanks to our speakers.